Okay, so math 1 3-4 arithmetic sequences. So there's two formulas that you'll need to know. So an arithmetic sequence is a sequence of numbers that follows a pattern. The difference between two consecutive terms is a constant called the common difference. The first formula is called the recursive formula. You're going to use this to describe a sequence to find the next few terms. So ace of n or ace is the nth term of the sequence. This formula requires you to know the previous term. So ace of n minus 1 means the previous term before, and then d is the common difference. This formula is not really used a lot in math. It's mostly used in coding. So if anyone gets to coding, this is pretty much used if you're ever trying to find the next term. This form is the one that you're gonna have to pay really close attention to because this is one's used to find a specific term in the sequence. So remember, ace of n means the nth term of the sequence. There's two things you need for the explicit formula. You need the first term, meaning the first number in the pattern, and you need the common difference. Those are the only two things you need when doing the explicit formula. So for example, we have this pattern 1, 7, 13, 19, and 25. If you're going to write this in the recursive formula, the only thing you need is the pattern, in which case every term increases plus by 6. So that means your common difference is just 6. So if I was going to write this in recursive formula, the only thing I need is just the 6. And then all you have to do is type in ace of n equals ace of n minus 1 plus 6. And this is used to describe the recursive formula. So that's all you gotta have to write for the recursive formula. For the explicit formula, there's only two things you need. You need the common difference, which is 6, but you also need the first number in your pattern. In this case, the first number in my pattern is 1. So that means ace of 1 is my first number. And all I have to do is plug it into the formula. Ace of n equals ace of 1 plus n minus 1 times d. D is 6 and ace of 1 is 1. And you just plug it in. You can leave it like this. I think for the online homework, you can leave it like this, but you can simplify it. Do distribution, which I'll teach you guys afterwards, but you can't, what's it called? Simplify it. Now, in this case, this formula is used to find the 15th term. So that means the 15th number. Now, you could do the long way and just keep going the pattern all the way to get to the number 15, but you can actually use this formula to get to that number without actually having to keep writing every number after 25 until you get to the number 15. So that's the whole point of why you want to use the explicit formula, because this formula will get you to the number that you want. And that's what we're going to do by practicing today. And it's just a lot of vocabulary. So for number 1, it says check whether the sequence is arithmetic. If so, find the common difference. So in this case, when it means check the sequence, it means is there a pattern? So from 9, 17, 25, 33, and 41, what is the pattern? Very good. Does it add 8 the whole way through? Because that's the important part. You have to make sure that it adds 8 between all the given terms. Because the moment one of them is not plus 8, then this is not an arithmetic sequence. So in this case, they all add up by 8. So your answer is just 8. See? Pretty easy, not too bad, pretty easy. So that's your answer. Number 2, it says determine if the sequence 5, 13, 25, 41 is arithmetic. And if it is, determine the first term and the common difference. So what's the common pattern between 5, 13, 25, and 41? Is it not? Okay. So how do you go from 5 to 13?
13 plus 8 is not 25.
So this is, what does 13 plus 25 give you? Sorry, 13 to get to 25. What are you adding? Good. And then from 25 to 41? Yes, 16. Do all of these share a common pattern? No. So this is not an arithmetic sequence, meaning there is no common difference. So see, it's not too bad. It's just learning the vocabulary. Okay. All right, so that's number 2. Let's go to number 3. Determine which of the following sequence is arithmetic. If the sequence is arithmetic, determine the first term, ace of 1, and then the common difference. So is there a pattern between 6, 9, 12, 15, and 18? Very good. What's the pattern? Very good. Make sure it's the same pattern all the way through. In this case, it is. So that means the first term, ace of 1, is what? What's your first term in the sequence? Very good. See, it's not too bad. And then what's the common difference? There you go. See, you guys learn math. You guys have learned math. So ace of 1 is 6, and then the common difference is just 3. But instead of saying the first term, we just write ace of 1. Okay, so that's number 3. We're going to get through pretty fast. Determine the sequence is arithmetic, completes A through D and below. So we have 1, 5, 9, and 13. The first thing we got to determine is this arithmetic or not arithmetic? Is there a pattern between 1, 5, 9, and 13? Very good. You're adding 4. You can also subtract, by the way, but we haven't gone to subtraction, but common difference is 4. Okay, so for part A, it says find the common difference. What would you type in for the answer? 4. Next, it says, yes, Nate.
I think I have.
For B, okay, we'll find the 8th term. What'd you get? How'd you get 29? Okay, very good. So in this case, you can just keep adding up to the 8th term. So this is number 1, this is number 2, number 3, number 4. All right, so 13 plus 4 is 17. 5, 21, 25, 5, 7, and then 29. Look at that. Nate was right. The 8th term is exactly 29. So 5, 6, 7, and 8. So very good. The 8th term is 29. Right, any question? Now it says find the recursive rule for the nth term. So when you're gonna do this on your homework, you're gonna do ace of n. So the n has to be in the bottom. If you're trying to figure out which button it is, it's the one where it's a square, and then the square that's on the bottom right. That's the button you're gonna have to press to get it in the n in the little bottom right section. So you gotta what? Yeah, it's an n. And then all we have to do is copy the same recursive formula that's right here. Ace of n is equal to ace of n minus 1 plus d. But in this case, we already know what d is, which in this case, it's 4. So ace of n equals ace of n minus 1 on the bottom plus d. But we already found the common difference. That's the only thing you need for writing the recursive formula, which in this case is plus 4. I will say that's probably the hardest thing about this lesson is, just plugging it into the formula. And that's where you're going to type in on the homework. But make sure that this is the button that you press to get it on the bottom right. And then n minus 1 is the same thing on the bottom right. Yes, it's always going to be minus 1. That does not change. So that's the recursive formula. Now it says to find the explicit formula. Now for the explicit formula, there's 2 things we need. Oh, sorry. Before we do go, Remember, for the recursive formula, the only thing you need is the common difference. But for the explicit term, there's two things you need. You need the first term. So what's the first term in my sequence? Very good. The other thing you need is the common difference, which in this case is 6. So the explicit formula requires you to know two things. And then all we have to do is write the explicit formula. A sub n equals a sub 1 plus n minus 1 times d. And then all we have to do is just plug in what we know. The first term we said was 1 plus n minus 1 times positive 6. And you can just type that in and that will be correct. Yes, Nate.
Which question is this?
This one is number 4.
Isn't the difference 4?
Oh, you're right. My apologies. You're correct. Thank you. Make sure it's 4. Do not write 6. I wrote the wrong number. It's not 6, it's 4. Thank you. All right. Any questions? Any questions? You guys good? Pretty easy, not too hard. Just write the formula. Okay. For number 5, it says write a recursive formula and an explicit formula for the following arithmetic sequence. So this one's a little bit tricky because now we have 425, 475, 525, and 575. What is the pattern? How much is it adding for every term if it is arithmetic? Not 25, not 0.25. 0.5, 50 cents. How do you go from $4.25 to $4.75? 50 cents. It's okay. You can use a calculator too to help you. But yes, in this case, the common difference between any term is 0.5. Okay, so now for we'll do the recursive formula first. This only requires the common difference, which in this case is 0.5. So plugging it in, a sub n equals a sub n minus 1 plus d. A sub n equals a sub n minus 1 plus 0.50 or 0.5, and then that would be the answer. For the recursive formula. Does anyone have any questions? Now that's a sub n. Now here's the thing. When you use the recursive formula, you always have to state the first term because it usually wants you to what's it called? When you start the pattern, you always want to know what the first number is, but it's not used in the formula. But usually when you're given the recursive formula, they always tell you what the first term is, but it's not used in the formula. Because on this assignment, this problem specifically, it's asking for the formula and then it asks you for the first term. Because usually when the recursive formula is given, you usually give the first term because that's where the pattern starts. Okay, so let's do the explicit formula next. So now the explicit formula requires the common difference and the first term, which is 425. So the formula is a sub n equals a sub 1 plus n minus 1 times the difference. So just plug in your numbers. A sub 1 is 425 plus n minus 1 times positive 50, and that is your explicit formula. Now you can simplify this by multiplying 0.50 and simplifying, but you don't need to. You can just leave it that like that on your homework, and I'll still give you full credit on it. Does anyone have any questions? Pretty easy. Number 6, it says write a recursive formula and explicit formula for the following arithmetic sequence. So it's the same thing. So in this case, what's the pattern for every term after each term? Not times 2, minus 2. I don't know who did say times. Okay, so recursive formula. This one, all you need is the common difference, which is -2, not +2. So a sub n equals a sub n minus 1 plus d. And all we're going to have to do is just plug in -2. So in this case, it's -2, not +2. And then the only extra little thing you have to say is that a sub 1 is 7. That's the only little extra thing you kind of have to give is the first term. Yes. Yes. Yeah, go ahead. Yeah. Sign up. All right. Any questions? Good. Okay, so that's the recursive formula. Now the explicit formula. This requires the first term, which is 7, and then we already said the common difference was -2. So a sub n equals a sub 1 plus n minus 1 times d. Now this one's going to be tricky because there's one little thing you have to be careful. When you do this on the calculator, or when you do this for the homework, you have to either do two things. Either one, put your multiplying by -2, or you're gonna have to plug in a sub n 7 plus n minus 1 and then put it in parentheses. So you're gonna have to be very, very careful. You have to be careful when you do it. You can't just put -2 at the very end because it's multiplying by -2. So you either put it in parentheses or put times -2. I believe it should still take the answer for. Actually, if it's negative, I recommend you just do it in parentheses. Just do it this way, where you have the two parentheses on it. Because I think it might not actually take this one. So just write it like this with the two parentheses. And technically with the previous one, you could also put parentheses, but this one in particular, you gotta make sure you put this in parentheses. Any questions? You can simplify it, that's not necessary. Okay, we're almost done, guys. We're almost done. Number 8, it says using the recursive definition of the following arithmetic sequence, find the second, third terms of the sequence, then write the explicit formula that represents the sequence. So we have a sub n equals a sub n minus 1 plus 5. A sub 1 is 13. What does a sub 1 equals 13 mean? Very good. It starts at 13. Now, this is the explicit formula. From the explicit formula, what information can we get from this formula? It goes up by 5. That's the common difference. The difference is 5. So if my first number is 13, what's the next pattern going to be? Very good. Followed by 23, then 28. And we answered the question already. Part A, it says give the second term, which we found out to be 18. The third term, 23. And then the fourth term is 28. See, so it's not too bad. Pretty easy, pretty easy. Getting the information from the formula. Now, the only thing it asks you is to write a recursive formula for it. Okay. Now, the only thing you have to be careful of is that this is not a sub n where it's a subscript, it's parentheses. So it honestly just means the same thing. So you're going to write it as a sub n equals, and then you have to find the explicit, yeah, a sub n equals a sub 1 plus n minus 1 times d. Now, what's the first term in the sequence? 13, right? And what's the common difference? 5. So if you want, you could just get in the habit of just putting in parentheses. So this would be the last part of the explicit formula. Now do be careful, it's not little a, this is capital A. And then it's not a subscript, it's just parentheses n, because over here it wrote it as parentheses n minus 1, didn't write it as a subscript. So you got to be very careful. So I think this is a good habit of just putting it always in parentheses. Yes. And it just depends on notation. Usually this is just another way of writing it. You can use capital A of n.
Oh,
But the other way is used more commonly.
gotcha.
Does that make sense? So there's not really much of a difference other than they mean the exact same thing for the formulas for recursive and explicit. But just for this one, just make sure you use capital A, because if you use lowercase a and then write this as a subscript, the computer is going to tell you it's incorrect, because it wants you to write it in the same format it had it for the original problem. Does that make sense? Yeah. So this is the one you just have to look out for. Okay, so for number 8, it says write an explicit formula following the recursive formula. So this is kind of similar to number 7. You just get the pieces of information from this. So remember, explicit formula, just write EF. You need the first term, and then you need the common difference. So based on what we're given, what is the first term? Very good. So this is the first term. So first term. And then what is the common difference in this case? Very good. The common difference is -4. And that's all we need. We have everything to plug it into the explicit formula. So a sub n equals -7, because that's the first term, plus n minus 1, and then the common difference is -4. And this is the explicit formula from the recursive formula. And just like I told you guys, whenever you write the recursive formula, usually the first term is always written with it as well. Does anyone have any questions? All right, last problem. This one is there wants you to write as the recursive formula for the following explicit formula and then find the first term of the sequence. So this is the explicit formula. A sub n equals 7 plus 4. And the thing about this problem is that it doesn't give you the common difference and it doesn't give you the first term. But what do you think I would have to do to find the first term for this equation? Take your best guess. It's kind of have to deal with what we did before. How would I find the first term? What? Yes. How would you find the first term? How would you find the first number in the pattern? What's your best? It is not 7.
Is it 9?
What?
Is it 9? Why is it 9?
Because it's the formula for the explicit formula. It's this formula. The thing is, what they took is that they took this formula right here. You know how it's like this? What they did was that they simplified it. They multiplied 4 times n, 4 times -4, and then they combined like terms. So it's unfortunate that it doesn't look like this because you could easily get the terms, but in this case, it simplified it. But what do you think I'd have to do to get the first number in my pattern? It's really not that hard. You're kind of close. I like the way you're thinking. No, go back to what you originally said.
Is it adding?
You are adding, but what do you think? It's this. It has to deal with what we did before in our warm up. Remember, we plugged in values, right? Right? Okay. So if I want to find the first, you're close. So, okay. So, okay. So you guys are getting close to it. So here's a hint. Ace of 1, right? Ace of 1 is the first term, right? How's that close to ace of n? What do you think I'd have to do to get ace of 1? What do you think I'd have to do to n? No, not divide. Yes, Nate.
Multiply?
You're not multiply. Okay, I'll give you guys the hint. To find the first term, you just have to set n equals to 1. Right? If n equals 1, ace of... I know, but I gotta make sure you guys understood why you added 4. 7 plus 4. Oh, sorry. 7 plus 4. Oops. Times 1 will give you the first term in the sequence, right? Because ace of 1 means the first number. So 7 plus 4 times 1. What number do I get? 7 plus 4 times 1.
Don't understand.
Yes, 11 equals 11.
It's for. You're thinking of.
Okay. So just like the previous problem, Coco, in the very beginning, we plugged in n equals 1, right? When n equals 1, ace of 1, that's the first number, right? So n equals 1, right? So what do I do with this n? Make it 1.
Sense. The formula like is different. 'Cause, like,
It-
you know how formula,
Yeah.
it's like.
Okay, the thing is, Coco, like I told everyone, it's this formula, but simplified. It's this formula. But what they did is they distributed and they combined like terms. Yeah, it's okay. So it's this one's for the hardest one. But what they did is they took this formula and they distributed. So just keep going and then I'll explain to you at the very end. Okay, so we plugged in ace of 1, right? To find the first term. If I want to find the second term, what do you think I'd have to do to n? Yes, Nate.
Change n to a different number.
What number?
2.
2, right? Because I want to find the second number, right? The second number in the pattern. So ace of 2 equals 7 plus 4 times 1. Oh, sorry, times 2, my apologies. So n equals 2, and I plug in 2 for n. So 7 plus 4 times 2 is what? 15.
I was just doing formulas.
Yes. Okay. Now let's find the next one because we kind of need at least 3. So we're going to find the third number in the pattern. Ace of 3 equals 7 plus 4 times 3. Sorry. So 7 plus 4 times 3 is 19. Okay. Now, based on the numbers that we have, 11, 15, and then 19, what do you think the pattern is? You're adding 4, right? To write it in the recursive formula, we need the common difference, which is 4, right? And it also, when you do the recursive formula, it wants the first term. What's the first term? 11. So to write the recursive formula, a sub n equals a sub n minus 1 plus d, which in this case is 4. Now, when you give the recursive formula, you always want to give the first term, which in this case is 11. So these are your two answers for the recursive formula. Does anyone have any questions?